Good day, everyone. My name is Idowu. I'll be teaching you mathematics on this platform, and I want to handle the class today, Junior Secondary School 2, called Grade 8. And we are starting with the topic whole number. Whole numbers are numbers without fractions or decimals, and they include factors, multiples, natural numbers, odd numbers, even numbers, prime numbers, integers. Let's take them one after the other as we are starting with factors. Factors of a number are other numbers that can divide the set number without any remainder. What do we mean? E.g., factors of 12 are 1, 2, 3. 2 can divide 12 without remainder. 3 can divide 12 without remainder. Also, 4 can divide 12 without remainder. 6 can divide 12 without remainder. And finally, 12. The factor of a number will include the number itself at the end. That is why 12 also is included in the factors of 12. Also, factors of 15 are 1. 1 is a universal factor. So 1, 3. 3 can divide 15 without remainder. Also 5 will divide 15 without remainder. And lastly, 15 will divide 15. The highest factor of a number is the number itself. The highest factor of 20 is 20. The highest factor of 30 is 30. The highest factor of 12 is 12. Don't forget. So that is that about factor. Let's move to the next concept. Let's come to multiples. When we say multiples, what do we mean? Multiples of a number are other numbers that the said number can divide without remainder. Take for instance, let's put a particular number there to be the said number. Let's put 5 and let's see how it goes. Multiples of 5 are other numbers that 5 can divide without remainder. Do you understand? E.g., multiples of 2 are the numbers that 2 can divide without any remainder. They are the multiples of 2. And they are 2, 4, 6, 8, 10, 12, etc. So these are the multiples of 2. What of multiples of 3? Multiples of 3 will be 3, 6, 9, 12, 15, 18, 21, and so forth. Multiples of 3s are the numbers that 3 can divide without remainder. So 3 can divide 3. 3 can divide 6. 3 can divide 9. 3 can divide 12, 15, 18, and so forth. Let me take 7. Multiples of 7 are 7, 14, 21, 28, 35, and so forth. So this is the idea behind the concept multiples. Let's move to the next concept. Let's consider natural numbers. Natural numbers are positive whole numbers only. Or we say natural numbers are counting numbers. The number a child counted at the early stage of life. No child counted negative or 0 at the early stage of life. In the years when we were using slates, there was no negative number on the slate, no 0 as a number on the slate. But what we have there is 1, 2, 3. Only the positive whole numbers. So natural numbers are positive whole numbers. The counting numbers, we call them counting numbers. So and they are 1, 2, 3, 4, 5, 6, 7, like that. Something must be noted. In between any two consecutive whole number, or so to say, in between any two consecutive natural number, the difference is 1. Between 1 and 2, the difference is 1. Between 2 and 3, the difference is 1. Between 3 and 4, the difference is 1. The word consecutive means following each other closely. Two consecutive numbers are two numbers that follow each other closely. 1 and 2, 2 and 3. not 3 and 5. You have jumped 1. In that case, it must be 3 and 4, 4 and 5. That is what we mean by consecutive. So, the difference between any two consecutive natural number now is 1. Therefore, in algebraic term, if the first number is x and the numbers are natural, the next will be x plus 1. The next will be x plus 2, followed by x plus 3, and so forth. So, if a question comes in that regard, please note it, that is what you need to do. Let's move on to the next concept. The next concept here is odd number. What are odd numbers? Odd numbers are numbers that are not exactly divisible by 2. Or we say numbers that are not multiples of 2. They are regarded as odd numbers. E.g., 1, the first odd number is 1, followed by 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and so forth. These are odd number sets. These are odd numbers. Note, the difference between any two consecutive odd number is 2. The difference between 1 and 3 is 2. The difference between 3 and 5 is 2. That is, if you subtract one from the other through positive difference, the difference will be 2. The difference between 5 and 7 is 2. Between 7 and 9 is 2, and so forth. If you don't jump, you make them to be consecutive, the difference between any two consecutive odd number will be 2. And the implication of that is, algebraically, if x happens to be the first number, the next one that should be odd number as well will be x plus 2, followed by x plus 4, also x plus 6. Definitely, these numbers are consecutive odd numbers. And whatever the value of x is, when you slot it in, you realize that they form consecutive odd numbers. And that one is applicable in technical questions. So anytime a question like that is posed to you, don't forget to refer to this concept. Consider the next concept, even numbers. Even numbers are multiples of 2, as straightforward as that. Even numbers are multiples of 2. That is 2, 4, 6, 8, 10, 12, and so forth. That's even number. So, and don't forget, the difference between any two consecutive even number is 2, just like that of odd number. The difference between any two consecutive even number is 2. The difference between any two consecutive whole numbers that are natural is 1. Now, in that regard, if x is an even number, the next to it will be x plus 2, followed by x plus 4, then x plus 6, and so forth. So, algebraically speaking, these are consecutive even numbers. Do you understand? Let's consider the next concept, which is prime number. When we say prime numbers, what do we mean? Prime numbers are numbers that have only 2 factors. The 2 factors are 1 and the number concerned. E.g., 2 is the first prime number, followed by 3, then 5, 7, 11, 13, 19, 23, 29, 31, and so forth. Why exclude 1 in the set of prime number? Because 1 has only one factor. The factor of 1 is 1, no other factor. And a prime number must have 2 factors. If it has more than 2 factors, it is not qualified to be a prime number. If it has less than 2 factors, it is not qualified to be a prime number. A prime number must strictly maintain 2 factors. And those 2 factors will be 1 and the number concerned. So, you can see we exclude 9. 9 is not part of prime number. 9 is not part of prime numbers. Why? 9 has 1, 3, and 9 as factors. 9 has 3 factors, so it's not qualified. You can see we exclude 15. 15 has 1, 3, 5, and 15. 4 factors. 15 has 4 factors, so it's not qualified to be a prime number. You can see we exclude 21. 21 has 1 as a factor, 3 as a factor, 7 as a factor, 21 as a factor, 4 factors. That's why it's not included. Also, we exclude 27. 27 is not a prime number because it has more than 2 factors. So, I want to believe you understand the concepts. Good. There is no irregular difference between any 2 consecutive prime number. It's the only one that does not have a regular difference. The difference between 2 and 3 now is 1. See, the difference between 3 and 5 is 2. Between 5 and 7 is 2. See between 7 and 11. See the wide difference. Also between 17 and 19 is 2. But between 19 and 23 is no longer 2. So it doesn't have a regular difference, common difference between two consecutive terms. The last concept there, integers. Integers are positive and negative whole numbers, including 0. So the set of integer is captured as this is it. This is the set of integer. So we believe that this has captured everything in integer. It includes the positive set of numbers, the negative set of numbers, and also the neutral, the 0. So that is integer. So we have positive integers, which are 1, 2, 3, the natural number part of it. And we have negative integers, -1, -2, -3, and so forth. So that is that about integer. So 0 is an integer. Any negative number, whole number, is an integer. And any positive number, whole number, so to say, is an integer. Do we understand? Good. Let's consider another concept, which we call prime factors. Prime factors are factors that are prime. Prime is just working as adjective to the factor there. Prime factor. So factors that are prime, they are prime factors. E.g., factors of 20 are 1, 2, 4, 5, 10, and 20. But among these factors of 20, which ones are prime? The ones that are prime, they are 2, 5. So therefore, prime factor of 20 are 2 and 5. Do you understand now? Factors of 20 are 1, 2, 4, 5, 10, and 20. But the prime factors among those factors are 2 and 5. I want to believe you understand now. So that is the idea behind prime factors. Let's consider this example under prime factors. Find the sum of prime factors of 60. All you need to do is, you will think you need to just list the factors of 60. No, there are many factors of 60. And after listing them, you now extract out those factors that are prime. Yes, you are correct. If that is what you think you want to do, you are correct. But there is exam approach to this kind of question. What's the exam approach? Take the 60. Divide the 60 by the first prime number, which is 2. The first prime number is 2. So 2 in 60 gives 30. You know, 2 can also still go in 30. But make sure you don't use a factor more than once in this approach. Now we have used 2. What is the next prime number? That's 3. Use 3. 3 in 30, that is 10. Make sure you don't use 3 again. Even if it goes, don't use it again. What's the next prime number after 3? That is 5. 5 in 10, that's 2. You can see that we come to a number that is lower than the next prime number. The next prime number after this 5 is 7. We have now come to a number 2 that is lower than 7. So that shows you have to stop there. Now, these 2, 3, and 5, they are the prime factors of 60 we can ever have. So instead of listing a long lines of factors of 60, and you now extract out of them the prime ones, instead of going on that Israelite journey, this is the exam approach you have to use. Use this exam approach. Once you use it correctly, it saves your time and it is accurate. Therefore, with this approach, the answer to the question, find the sum of prime factors of 60, is 2 plus 3 plus 5, which is 10. Or you need to first say the prime factors of 60 are 2, 3, and 5. Therefore, the sum is 2 plus 3 plus 5, which is 10. And that is how to answer such question. Let's consider another example. Example 2, under that, prime factors. Find the product of the prime factors of 20. All you need to do is to extract the prime factors of 20. And I have told you, you don't need to list a long line of factors of 20 before you extract the ones that are prime there. If you do that, you are correct. It's good. But you don't need that in exam situation. It will waste your time. So bring 20 here. What is the first prime number? That's 2. 2 in 20 gives you 10. But then, don't reuse that 2 again. What is the next prime number? That's 3. 3 cannot go in 10. What is the next after 3? That is 5. 5 in 10. That's 2. You have come to a number that is less than the next prime number you want to consider. So you stop there. Meaning that 2 and 5 are just the prime factors of 20 we may have. Therefore, you see, the prime factors of 20 are 2 and 5. Therefore, their product is equal to 2 times 5. Product is multiplication. 2 times 5 is 10. Coincidentally, our answer for the example 1 was 10. And our answer for example 2 is 10. It's just a coincidence. It's not going to be like that always. And that is that about prime factors. Let's come to the subtitle. Expressing numbers as a product of their prime factors in index form. Example 1. Express 98 as a product of its prime factors. The question does not say in index form, so you are free to leave it without putting it in index form in that case, depending on the question. So what do? Take the 98. What is the first prime number? 2. Use 2 to divide. 2 in 9 is 4. Remains 1. Use the 1 with 8, giving you 18. 2 in 18 is 9. The next prime number is 3, but it will not go in 49. The next is 5 after 3, and 5 will not go in 49. The next prime number after 5 is 7, which goes in 49. So we use 7. 7 in 49 is 7. 7 goes again, give you 1. Don't be confused. This work is different from the exam approach I told you about in the previous work, when you have to find the sum or product of prime factors of a number. I taught you a short way of extracting your prime factors, in which I told you that you should not repeat a factor you have used once in division. The case is not related to this. Here, we are to express the number as a product of its prime factors. So you have to use everything. If 7 goes in 49, 7 times. 7 still goes in 7, you still use it. And gives you another number that 7 can still divide, you still use it. Therefore, 98 is expressed as 2 times 7 times 7. That is as a product of its prime factor. That's the answer. Let's consider example 2. Express 279 as a product of its prime factors in index form. This one emphasizes index form. So what do? Bring your 279 here. The first prime number is 2, but 2 cannot divide 279, as you can see. So the next prime number after 2 is 3. Yes, 3 can divide. 3 in 27, that's 9. That's 9. 3 in 9, that's 3. 3 can still go. Can still divide 93. 3 in 9 is 3. 3 in 3, that's 1. The next prime number after 3 is 5. It cannot divide 31. The next after 5 is 7. It cannot divide 31. The next after 7 is 11. And that 11 cannot divide 21. In a nutshell, the next that can divide this 31 is 31. So it divides it. Therefore, 279 is expressed as a product of its prime factors in index form as 3 raised to power 2 times 31. It is 3 times 3 times 31. But because we are to express it in index form, so 3 times 3 is 3 squared times 31. That is the answer. That is how to express this kind of number as a product of its prime factors in index form. Let's consider the last example I have for you under this subtitle. Express 72 as a product of its prime factors in index form. Take 72 here. The first prime number, which is 2, use it to divide it because it can divide it. 2 in 7 is 3. It remains 1. That one being used with 2 gives us 12. 2 in 12 is 6. 2 can still go. 2 in 36, that is 18, because 2 in 3 is 1. Remaining 1. Use that one with 6, making 16. 2 in 16 is 8. 2 can still go. 2 in 18 is 9. So 2 can no longer go. You use the next prime number, which is 3. 3 in 9 is 3. 3 in 3 is 1. Therefore, 72 is expressed as a product of its prime factors in index form as 2 raised to power 3 times 3 raised to power 2. 2 is in 3 places. That is why it is 2 raised to power 3. 3 is in 2 places. That is why it is 3 raised to power 2. That is 2 in 3 places, 3 in 2 places. And that is how to express it.